Hello, I'm Mr. McBrien. This is TEJ20, solid state memory. Yesterday we talked about the storage of information to which we wish to have access days or years from now. Today we're going to talk about other kinds of storage, particularly storage that doesn't have moving parts. So before we begin, see if you can remember from yesterday, what's the access time for a hard drive? How much time does it take between the CPU requesting a bit to that bit being retrieved? So, if you remember, roughly 9 or 10 milliseconds is the time that it requires for the hard drive to spin up, for the actuator to move the read head to the right location, and for that bit to be retrieved. Obviously, there's some variables there. Now, if we contrast that with dynamic RAM, DRAM, we can see that we can retrieve a given bit about 200,000 times as quickly. So our retrieval time is about 50 nanoseconds instead of 10 milliseconds. So that 200,000 times improvement leads us to revisit this idea of memory versus storage. Hard drives store all the stuff that we need. All of our cat videos, all these kinds of things, they're like the attic where we place everything we might need someday. RAM, in contrast, is working memory, the things we're worried about today, the things we're worried about at this time. So this might be a data file that is being processed, or it could be applications that have been loaded. So each tab in Chrome takes up some amount of our RAM. Now this leads us to the understanding of why that 200,000 times difference in access speed is so valuable. The more RAM we have, the less often the computer has to go back to the hard drive to retrieve information. If we fill up all the RAM, then we have to start using the hard drive as storage for the things we're working on at this time. And this is when we start waiting for the hard drive in order to do a given process. So we actually covered most of that yesterday, to be honest. Today, instead, we're going to talk about the physical basis of dynamic RAM and talk about the other kinds of solid-state memory. So RAM is actually a system of really closely, really densely packed transistors and capacitors. The transistors control the flow of information. The capacitors actually contain the information. A given capacitor on the RAM module can contain a single bit. So reading or writing that bit requires transistors, switches that have to turn on and off. Now, this would be fantastic and is fantastic, but it has one facet that's kind of interesting. Capacitors lose electrical energy over time. And so what this means is that a given bit will erase itself over time. The only way we can prevent that is to read the contents of the bit, decide whether the contents are zeros or ones, and rewrite that information back. And this is what we mean by dynamic RAM. The D in DRAM is that refreshing requirement. So thousands of times per second, the memory controller reads a given bit and then rewrites the 0 or 1 back to that capacitor. And so we can think of this as being like disappearing ink, like a henna tattoo. If we want to keep it, we have to go back and rewrite it on a regular basis because it will slowly fade. Now, dynamic RAM isn't the only kind of RAM in your computer. There's also static RAM. And static RAM is much more complicated than dynamic RAM. It has extra transistors that prevent it from having to be refreshed, so the information doesn't fade in the same way. Now, this lack of a refresh requirement means it can be accessed more quickly than the dynamic RAM. The downside is it's much more complicated, and thus it costs more money and space. And so we have less of this than we have dynamic RAM. Modern computers use the static RAM concept for the CPU cache. And so that information is very quickly available, and this is like Uber RAM. So it's the things it really, really needs right now, the calculations it's doing right at this time. It's temporary storage for the CPU, things that it's working on right at that second. And the typical access time for static RAM is about 5 times as fast as dynamic RAM. And that 5 times increase in speed, you can imagine, can be extremely valuable. Okay, well, in terms of upgrading computers, the best bang for your buck in upgrading a computer is typically looking at your RAM. You can do memory upgrades without having to replace the entire computer. You can simply add or replace the RAM modules that are on your computer. There are lots of options for these. The only catch with these upgrades to a computer is that you have to be very careful to make sure that the RAM you buy is suitable. You have to match every parameter for the RAM, except of course the size. And of course you don't want to exceed the limitations of your operating system or your motherboard, because if you do, you will have bought a very expensive conversation piece. It won't increase the performance of your computer at all. By the way, do you remember from yesterday what the limitation of the motherboard, what parameter in the motherboard causes that limitation in size of RAM? If you don't, you can go back and look for that. Now, the good news here is you don't have to be a rocket scientist to determine which RAM is most appropriate for your computer. Particularly Crucial.com, they will look at your computer that you're using and make recommendations of the best RAM based on your computer and your motherboard. And you can go ahead and get the parameters from the RAM they recommend. Verify it, of course. But they're in the business of helping you to make it easy to upgrade your RAM. And once you do this, of course, there's nothing wrong with, once you know the parameters of the RAM you want, with using other websites to do price comparisons. Now, when you're doing your price comparisons, don't forget to make sure that the quotes are in Canadian dollars, and make sure that you're also considering shipping. So you have to consider your all-in costs before you decide which RAM you want to buy. Okay, some other sorts of solid-state memory. We already referred to read-only memory. We talked about how it's non-volatile. It remains when you power down the computer. And we talked about where read-only memory can be used. It's typically on your motherboard, storing things like your BIOS. But how does ROM store that information? Well, it depends on which year it is, how that gets stored. But we've been making a transition from one kind of read-only memory, EEPROM, electrical erasable ROM, and making the transition to what has become very familiar, flash memory. And this is still certainly an evolving field. Notice, though, that the read-only memory does not mean permanent. You can still update this information. So we need to be able to make, for example, security updates on our BIOS at some times. Sometimes the BIOS can get corrupted and we need to restore it. So this kind of control software that is kind of permanent, kind of not, we refer to this as firmware. Now, flash memory has other applications as well. So we can also use it for more traditional storage, solid state storage that has advantages beyond things like its read-only status. So we have our traditional flash drives that we use the way the ancients used a floppy disk. And we have solid state non-volatile storage like in an SSD. And bits are stored really in a way that isn't much different than SRAM, to be honest. We store a bit by having a transistor that remembers its state, retains a small amount of information as electrical energy. But the difference is that this can be stored for a very long time. So it's accessible at a given time based on simply going back and opening up the transistor to allow the electricity to flow out. So flash has a number of advantages. Of course, number one, it's non-volatile. It's faster than our old spinning magnetic hard drive. It's also more durable in cases where there's a lot of physical manipulation of a given device, like a phone. It's lighter and more compact than a hard drive, another advantage for these mobile applications. Now, in terms of how long flash memory will last, there's two ways of interpreting this question. So we can think in terms of how long will our cat video remain in flash memory if we leave it alone. The answer is about 10 years. However, there's another interpretation of that question. Unlike hard drives, solid-state drives will wear out when data is regularly written and erased. So those sets of transistors will wear out. And so by most accounts, you can overwrite a given bit on an SSD or a flash drive about 1,000 times before it will start to fail. So it's probably a good idea for us to sum up then these three different kinds of memory. And you should be sure that you can remember these different aspects. Now, if you pay attention to the given parameters here, you should be able to see why these kinds of memory are applied where they are. So dynamic RAM is volatile. It requires power to be retained, the information. It also has to be refreshed about 1,000 times per second. It can be accessed very quickly, about 50 nanoseconds to retrieve a bit. We typically have on the order of 10 gigabytes in a computer. Some will have more, some will have less. Its application is as working memory for the computer. And its durability, it can be read and written many, many, many times. such that the technology is likely to be out of date before it wears out. Static RAM is also volatile. It has to be under power to retain bits. It, on the other hand, does not need to be refreshed. Its access time is about 5 times as fast as dynamic RAM, but it's much more complicated and expensive, so we typically have much less of it. Its application is as the cache in the CPU. And again, it will outlast probably the technology that you're using in your CPU. Flash memory is non-volatile, doesn't need to be refreshed, so it doesn't need to be kept under power, doesn't have to be rewritten to be retained. Its access time is pretty good, about 1/1000th of the speed of static RAM. Size, roughly half a terabyte. Depends, of course, whether you're talking an SSD or other applications. Its application, long-term storage, including the BIOS on your motherboard. Its durability, it can be overwritten about 1,000 times before wearing out. Okay, so let's sum up then. RAM is volatile solid-state storage. It requires power to retain information. Dynamic RAM is used for memory, the data that the current computer is currently using. Static RAM is used for the cache on the CPU, extremely temporary storage to support the CPU's current thought process. Flash memory is non-volatile. It can keep data for years without being under power. And flash is used for long-term storage, like solid-state hard drives storing your operating system and the BIOS on your motherboard. Okay, for your homework then, go ahead and complete the RAM question sheet and then start your RAM upgrade assignment. If you'd like to do some more reading on this, there are lots of excellent utilities, lots of excellent references online for you to read in more detail. Thanks very much. Have a great night.